Okay, I am here to help if you're still struggling with graphing or solving with substitution. So I'm going to start on the right side here and solve this using substitution. So the beauty of this problem right here is that on this second equation, both x and y are by themselves. So because of that, I have a choice here. I can either solve for x or I can solve for y. Now, because I do need to graph these as well, I'm going to go ahead and just solve for y. So in order to do that, I need to subtract x from both sides. And I end up with y equals negative x plus 9. Now, with the information that I just found there, I can take this y, I'm going to make y orange, and plug it into that first equation. So instead of writing 2x minus 3y, I'm going to write 2x minus 3 times the quantity of x plus 9 equals negative 12. Okay, and then from here I would just solve this equation normally. So I'm going to distribute this negative 3. Now remember that negative sign sticks with the 3 there. So when I'm distributing, I distribute the negative 3 to the negative x, and that becomes positive 3x. Then the negative 3 to the 9, which is a negative 27. And then I would need to combine like terms. 2x and 3x here are alike, and so that becomes 5x minus 27 equals negative 12. I add 27 to both sides, and I get 15 equals 5x, and then I end up with x equals 3. Now I'm not done because I need to put that 3 back into the original equation that I solved. So I'm going to rewrite that original equation here. And notice that negative is a part of that equation. So if I make this x blue here, the only thing that I replace that's for that x is that 3. I'm not changing the sign out front. All I'm doing is changing the number. So that I would solve y here is equal to 6. So if I have x is 6 and y is 3, then the solution to the system is 3, 6. And because my graph was printed so poorly here, I'm not going to actually graph those lines, but I am going to solve those equations for y so that y'all can get used to that. So just so I have enough room, I'm going to go ahead and erase some of that work, and I'll solve both of those equations here for y. So that first one looks a little hairy, but it won't be too bad. The second one we actually already did, and we said that y was equal to negative x plus 9. So I could easily graph that by plotting my y-intercept here at 0, 9, putting a 1 in front of that x, putting it over 1, and having that rise be negative 1, and the run be positive 1. And then for the first equation, I'm going to write that in orange, I just need to get y by itself. So I got two options here. I can add 3y to both sides, or I can subtract 2x from both sides. Now, I don't like to deal with negatives, so I'm going to kind of anticipate what's going to happen here. If I add 3y to both sides, my x stays positive, my y becomes positive, and I don't have to deal with adding and subtracting a bunch of negative numbers. And so again, just kind of anticipating what I want to happen here. I now end up with all positives, and I didn't have to multiply or divide by a negative 1. So for me, that's a win. And I'm going to rewrite that right here. So it's then y, I'm just flipping that around, that was equal to 1. And that's equal to 2/3 x plus 4. And again, really easy to just plot that y-intercept at 0, 4. And then my rise is 2, and my run is 3. And then you could plot that on that graph. And yesterday we talked about how to check in the calculator as well, so you can pull out those notes from yesterday and check there. Now we're going to move on to number 4. Okay, now this is a funky solution because my x here is vertical. That's something that I can't check in my calculator. But the cool thing about when x is -3 is x is already isolated. So I can replace in that first equation x with -3. And then I do -3y equals -15. And then just solve for y. So I'm going to add 3 to both sides here. I get -3y equals -12. And I'll divide both sides by 3. So y is equal to 4. Now, because I know y is equal to 4, I can't plug that y into the equation that we just used, so I gotta plug it back into the original. Now, if you think about it, do you really need to plug y in? No, because if they're going to intersect, x has to be -3. But we're going to go ahead and prove that, just so we're not getting confused there, and we're going to see that it's going to equal to -3. So I have -3, and then I'm going to times that by 4, and then that's equal to -15. So -3 times 4 is -12. And I add 12 to both sides, and I get x equals -3. Now we knew that because of this equation here. Because if they're going to intersect and a line only has x values of -3, then they have to intersect where x is -3. So my intersection point then would be -3, 4. And again, we would also be able to find that solution by graphing. And x, remember, that's the VUX, the v vertical line, undefined slope, and the x is at -3. But for that other equation, I'm going to anticipate what's going to happen here again, and I don't want to deal with negatives. I just don't really like negatives, and I don't really like fractions. So if I can anticipate what's going to happen here and get rid of them before I have them, then I'm going to be a happy camper. So you see me here solving these equations so that I have positive numbers and I don't have to deal with negatives. And if you had a different way to do this, that is totally fine. I just want to make sure that I'm doing it correctly and I don't want to deal with those negative numbers. So 15 divided by 3 is 5, and that's equal to y. So we talked about on that other slide how this was our y-intercept, and this told us our rise here, which is 1, over our run here, which is 3. Okay, so moving on to that next equation. This one's a little more tricky, just because I have a 9 in front of that y and it doesn't really go into that 2, but that is okay because it doesn't need to go in perfectly. I can just put it in as a reduced fraction. First thing I want to do, though, I was talking about the graphing part, is just solve by substitution. So I'm going to add 3y on both sides, oops, and my second equation can be rewritten as 3y minus 24. If you did -24 plus 3y, that is absolutely okay. So now that I have x by itself, I can plug it into that original equation where I see x, and I'm plugging that in so that I have one variable so that I can solve for it. Okay, and then I distribute. And then I need to make sure that I combine like terms first. That's 15y. And I just bring down that -48. And then I'll add 48 to both sides. So I end up with 15y is equal to 75. So my last step here will be to divide by 15. So y is equal to 5. Okay, now that I know that y is equal to 5, I can plug that back into this equation up here. And I'm going to rewrite that over here, and I'll make y blue this time. So x was equal to 3 times my y that I just found here, which is 5, and then I'll subtract 24. So x equals 15 minus 24, and then all I have to do is reduce that. So x equals negative 9. So if x is equal to negative 9 and y is equal to 5, then my solution here would be negative 9, 5. Now, I solved for x in order to solve this because I didn't want to use fractions, but if I'm going to graph it, I want to get y by itself. Now, I'd recommend that you just graph from standard form just to kind of make your life easier, but if you are wanting to check in your calculator, you need to get it into slope-intercept form. So I'm going to go over how to do that. So I'm going to erase this, so pause it right now if you need to see that work again. And I'll convert both of those equations into slope-intercept form. So I'm just going to get rid of all that and start fresh. So I start with 2x plus 9y equals 27. So my goal is to get y by itself. So I know I need to push everything away from y that's on the same side of the equal sign. So I end up with 9y equals negative 2x plus 27. And I wasn't trying to erase that, but it kind of smudged together. Now, in order to get y by itself, I just have to divide both sides by 9. So y is equal to, leave it as negative 2/9 because 0.2 repeating is not a fun decimal. So that would be equation number 1. Equation number 2, just like I was saying on the other problems, I'm going to kind of anticipate what's happening here to start. If I want to start with the x or with the y. Now, I know that I want y by itself, and I also want y to be positive. So because of that, I'm going to start by adding 3y on both sides. And the purpose of me doing that is so that y becomes positive, because I see that that 24 is negative, and I'm going to have to move it over 2. And I know that because I'm just anticipating what I'm going to have to do. So with what I know of how to solve equations for variables, I know that I'm going to have to get y by itself. And then I would divide everything by 3, and y would be equal to 1/3 x plus 8. Again, where we were saying we'd plot those y-intercepts and use the slope as rise over run. Okay, last one here. X is already solved for, so I'm going to use x and plug it into that second equation. So instead of writing x right here, I'm just going to write out 4y, and then I'll write out everything else exactly as I see it. Now this one's a little bit easier because I don't have to distribute, so I just combine my terms that are alike, and I get 6y, and when I divide both sides by 6, I get y is equal to 2. Now again, it's really easy because I had x was equal to 4y, so if I just found that y was equal to 2, I'd have x is equal to 4 times 2, which gave me 8. So the solution to this system is 8, 2. Now, in order to graph it on this handy dandy graph, that copied so poorly at my house. I want to make sure I get y by itself. So yes, I will be dealing with fractions, but because I'm not manipulating those in solving a system, I don't really worry about the fractions. The fractions help me when I'm doing slope. So for this first one here, to get x on the same side as the 4 there, or y by itself, I just have to divide both sides by 4. Now there's an understood 1 in front of that x, so I'm actually going to write the 1/4 separate of the x. So y is equal to 1/4 x. So that will go through your origin. And then I'll do the second one in orange. Again, I want to get the 2y by itself, and there's no weird negatives here. So I'm just going to start by subtracting x on both sides. I get 2y equals negative x, plus 12. And then I divide both sides by 2. Make sure you're getting everything there. There's an understood 1. So I'm going to write the 1/2 next to the x, and then I'll add 6. So again, we can plot those y-intercepts. And this one doesn't have one, so it just started at the origin. And then use our rise and our run to plot that slope. So I hope this helped. I know it was a long video, so just remember you can start, stop, pause, rewind, fast forward at any point. Y'all have a great weekend, and I hope the activity went well today.